recording. Okay. So what is, file system? The definition, the basic level definition for file system is a collection of files and directories. This is a basic level definition. And when we talk about admin level definition is the file system is a control structure, right? Which prepares the disk to read, write, and modify the data in a predefined manner is known as file system. When I say file system is a control structure, when I say that file system is a control structure, so remember what is control structure, right? So when we talk about the control structure, the first thing here is what we say control structure in a sense here, primary super block, backup primary super block, and then we have something called inode block. Then we have something called data block, or it is called logical block, you know, and we have fragment. Okay, so this is what exactly. Then apart from this, when I talk about inode block has the information such as, you know, total, used, and available. This is what exactly we have. We have something called total, we have something called used, and we have something called available, right? So this is something called control structures. Now you might have a doubt, can I view this control structure? No, you can't view, right? It is an internal architecture of your file system. As you create a file system, it gets created. You're getting my point. Okay, this control structure only prepares your raw disk into a block disk. Remember this, this control structure will convert the raw disk or a partition into block, right? Remember this is very important. Okay, so this is all about it, the information here. Okay, primary super block, it's very, very important, you know, it is like a metadata for your file system, metadata for the file system. Okay, you know, if the super block is corrupted, you will not be able to access the data on your file system. Remember, that's very important. Okay, so this is something called control structure. I hope you understood what is control structure here. Okay, so now good, we have discussed about the control structure here. Now well and fine. Now let us go with every operating system contains their own and unique file system. As you know that you're using Windows from long time, right? You know what is a file system that is used on Windows? FAT and NTFS. Tell me where you can find the file system information. Go to the this PC or my computer. There you will see a C drive. Right click on the C drive and see the properties, and you will see that there is a file system with the name called NTFS is running there. NTFS is a file system created there. NTFS stands for New Technology File System. New Technology File System it is called, right? And when I talk about Linux, when we talk about Linux here, Linux has, you know, wide range of file systems here. If I talk about ext2, ext3, ext4, XFS, GFS, and GFS version 2, okay, GFS version 2, right? And we also have a B tree file system that is called binary tree file system. We have a VFAT. This is what exactly we have. This is something called Linux file system. This is something called Linux file systems, right? And you know that the default file system inside the Linux is XFS. And you know where this GFS version 2 Gluster, it is called Gluster file system, GLUSTER, Gluster file system it is called. We are going to use this Gluster file system especially for clusters. You know what is clusters? We already discussed clusters is nothing but the two machines that provide one single service. See, this is one machine, this is one machine. You will be running the same OS, same application on the two machines. This is a Linux, this is a Oracle, DB you are running. The same applications, same users will be there on the other machine also. And these two machines are internally connected like this. And it is going to have a common storage here. This is a common storage, and the database will be accessed from this common storage, and the database is available for two machines with the help of GFS file system version 2. We are going to use GFS version 2. Remember, you're going to create like this. You getting that? This is something called cluster file system. So whenever you're going with Red Hat clusters, you are going to see this GFS version 2. Getting it? Now, what is the advantage of cluster? You know, if this machine is down, still the users can access the applications and data from this machine. Right? Especially clusters are used for two reasons. One is failover. The other one is load sharing. One is failover, another one is load sharing. Failover means one machine is down, another machine will take care. Load sharing means if you know, it will try to distribute the load among the two machines. This is what exactly. Are you getting that? This is the major purpose of clusters. And AIX has its own file system like JFS and JFS2. Solaris has its own file system. So every operating system has its own file system, right? Now we are going to discuss what is partition, right? Why we need to create a partition. See, you're using Windows, right? Okay, you're creating a partition in Windows, right? Okay, you're creating C, D, E, F. Why you're creating a partition? Assume that we have a 1 TB hard disk. This is 1 TB hard disk. Assume that this is a 1 TB disk we have. This is a 1 TB disk we have. Okay, this is a 1 TB disk we are having. So how you are going to use this 1 TB disk? Okay, can I create a 1 TB disk as a single partition called C? Yes, can I do it? Yes, please answer. Yes, we can do. So what will be the problem? You know, in this C drive, the total entire 1 TB is converted into one single partition. That means OS and user data, user data will be on single partition. So you'll say, what's the problem, boss? The problem here is if suddenly some virus affects your machine, if OS goes down and you want to reformat it, okay, you want to install the OS. With the OS data, even user data is lost. There is no safety, there is no security, there is no privacy, right? This is a problem. So that's the reason what we do is very simple. When we have a disk, 1 TB disk, when we are having a 1 TB disk, instead of converting this entire 1 TB disk into one single partition, we try to divide the disk into partitions here. We try to divide the disk into partition. Okay, this is something called C. This is something called D. This is something called E. This is something called F. This is what it's. Assume that C will be 250 GB. Okay, D will be 250 GB. And E will be 250 GB. And F also will be 250 GB. Right? Now what I'll do, I'll try to put OS on the C drive, user data on D, E, F. If suddenly something goes wrong with C, format it, install it, still your application data, user data is safe on C, I mean D, E, F. Right? So this is a purpose. This is a reason why we create a partition, right? In the same way, inside the Linux also, we also create partitions like C, D, F, but it is not called C, D, E, F. It is called root, var, OPT, USR, home. Like this, we have a different names, right? We will discuss detailing about it. Okay, so now let's get into the document here. Let me show you. A partition is an act of dividing a hard disk into multiple logical storage units referred to as partition. right? To treat one physical disk drive as if it were multiple disks, okay? So that different file systems can be used on each partition, right? So you're creating a different partition like this. You are dividing a disk, like we have a disk here. Assume that you created a partition like this. Take an example, 10 GB, 10 GB, 10 GB, like this. You created a partitions, right? So assume that this particular disk name is SDA. Assume that disk name is SDA. Now what will be the partition name? The partition name will be SDA1. The partition name will be SDA2. The partition name will be SDA3. The partition name will be SDA4. The partition name will be SDA5. The partition name will be SDA6. This is what exactly, right? So take an example. On first partition, I will try to create XFS file system. Okay, on the second partition, I will try to create ext4. On the other partition, I'll try to create ext3. And another partition, I can create XFS. Like this, you can create whatever the partition, file systems you want. Here we can create VFAT. This is how exactly it's going to be. Is this clear or any doubt? Is this clear or any doubt?
Yes, sir.
Right? So this is how exactly it is going to work. This is all about how the partitioning and file systems are going to work, right? So this is what exactly to treat one physical disk drive as if it were multiple disks, so that different file system. This is what exactly. Okay, so the types of partitions. Basically, you should remember one thing here: inside the Linux, in one disk, in Linux. Okay, in one disk, on one disk, we can create 15 partitions. Okay, we can create 15 partitions, right? 1 to 15. Okay, and in order to create 15 partitions, we have to follow the partition rule. We need to follow the partition rule. So what is this? Following the partition rule here is very simple. We need to follow like primary, extended, and logical. But you'll ask me how many primary? Max. Okay, 3 primary. I'll just try to put 3 primary. Okay, and 1 extended, remember, and rest all logicals. Rest all logicals. This is what exactly. Rest all means 3 plus 1, 4, 4 plus 11 is the logicals. This is what exactly we need to follow, right? But remember one thing, I'll just try to put a note. In one disk, note, just make a note. In one disk, we can create max 4 primary partitions. Okay, 4 primary partitions. Okay, only 4 primary partitions, right? If you create 4 primary, right, it doesn't allow you to create extended or logicals. But if I want to create 15 partitions, then what we need to do? We need to follow the 3 primary, 1 extended, the rest of the things should be logical, right? So you might also have a doubt, why primary 4 only? Why not 15? Okay, so the question, the reason here is not now exactly, 10 years back or 15 years back, when we don't have virtualization. Right now you're using VMware, right? Previously we don't have VMware. We used to do DL booting. DL booting means what? We have it 40 GB hard disk, 20 GB is for Windows, 20 GB is for Linux. So the partition where we used to install operating system, that should be a primary. Okay, that means in one single disk we can install 4 operating systems. We can install how many? 4 operating systems we can install. We can install how many? 4 operating systems we can install. You're getting my point. We can install 4 operating systems. This is what exactly happens. Okay, so this is what exactly. But if you install even 4 operating system, you can work only with 1 operating system actively. If you shut down Windows, then you should boot up the Linux. If you shut down Linux, you should boot up with the Windows. Like this it is to work. You can't use parallelly all the operating system. That's the reason to break this, they have come up with virtualization. See, in virtualization, what happened? You're trying to use Windows, you're trying to use Linux, right? This is what exactly. Okay, so this is the reason here. So you need to always follow the partition rule. So when I'm talking about the partition rule here, so take an example. This is my disk, assume that, right? It is a, assume that a 1 TB hard disk we have. We have a 1 TB hard disk, 1 TB disk. And what you will do is I'll try to create one primary partition as 100 GB. And I'm going to create another primary partition with 100 GB. I'm going to create another primary partition with 100 GB, right? So you can just see 100 GB, 100 GB, 100 GB, right? So this is primary, P for primary, P for primary, P for primary, right? So this is 3 primary partitions. After creating 3 primary, how much disk space is left, boss? Well, there is 700 GB is left. That's it, right? 700 GB is left. This 700 GB we will try to convert into extended. We will try to convert into extended, right? And after converting this 700 GB extended, we will, give me 1 minute, please. 1 minute. Like we have a 700 GB here, right? This 700 GB is called extended partition. Remember, this 700 GB is called extended partition. Remember, this 700 GB is extended partition. So extended partition is used to create logicals, not to store any data. Remember, extended partition is to create only logical, not to store any data. Now this 700 GB, whatever it is there, on the top of this 700 GB, we will try to create a logical partitions like this. You're understanding? Understanding? How many we will create? Up to 3 plus 1, 4, 4 plus 11, up to 11 logical partitions. If you want, you can create logical 11, or you can convert entire 700 GB into one logical partition also. It's up to you. This is what exactly it is going to happen. I hope you understood. I hope you understood. Right? Any doubts here? Yes, boss. Any doubts here?
No doubt.
No doubts. Ma'am, do you have any doubts?
No, sir.
Shraddha, do you have any doubts?
No, sir.
No? Okay, fine. You're clear. Why? Because these concepts are very core concepts. If you understand this, I know it will be easy for you to work practically. So this is what exactly it's going to be. So it's clear. So now we will just go with how do we create a partition here. Let me show you. There is a command with the name called fdisk. Fdisk is a command to create a partition. Fdisk to create partition. Okay, fdisk to create a partition. So what I'll do is very simple. I'll just try to get into the machine. So yesterday, I showed you how to create a disks and how to detect the disk. I showed you, right? So we try to use that the same disks. Okay, so last day we have seen LSCSA is a command to list the disks. So we have totally a 4 disk we have. this is a disk where the operating system is running. If you want to know where the operating system is running, try to run lsblk. So in lsblk, you will come to know that in this particular disk, the OS is running, because you will see the mount points. Can you see this? The rest of the disk are just an empty disk. There is no partition, there is no data running on it. Can you see this? And each disk capacity is 20 GB. Can you see this? 20 GB, 20 GB, 20 GB. And you know what is SR0? It is a CD-ROM. It's DVD-ROM. Okay. So what I'll do is very simple. I'll try to show you how do we create a partition. fdisk-l/dev/sda. So when I just press and enter, you will see that there is a disk with the name called SDA. It is 20 GB, and this is a size in bytes and sectors. And right now we don't have any partitions in it, right? So what I'll do is very simple. I'll just try to remove this EL, and I'll just try to go fdisk followed by /dev/sda, right? As I press and enter here, just see. But before we go into the command, let me show you the man page, because it's mandatory initially to go with the man page. So fdisk is nothing but a manipulate disk partition table, right? Fdisk is is a dialog driven program, it is called. Why it is called dialog driven? Because when you run fdisk, it gives you a proper menu in order to create or manipulate the partition table, right? And it understands all these partition tables. Okay, we will discuss about these partition tables later. So what I'll do is I'll just come out of it. What I'll do, fdisk followed by /dev/sda. I'll just try to press and enter. Then I'll just try to put p for print, right? It gives you that there's a disk information, and disk label type is DOS. Disk label type is DOS, right? And then I just try to, because I don't know how to use the thing, I'll just try to put em. So then I'm just going to put em. Em is nothing help. And what I do is very simple. You're going to get some help here. Now there are so many things is there. So you need to go with this generic commands, right? And to save this, you need to go with save and quit, right? So just see the generic commands. N is to what? Add a new partition. P is to print a partition table. V is to verify the partition table. L is to list the known partition table. D is to delete a partition table. Can you see this? This is what exactly it's going to be. This is how exactly it's going to be, right? So now what we will do is very simple. I'll just try to what we say, I'll try to create a partition here. So first I'll just try to say p for print, and n is to add a new partition. Just see here, as I just say n, okay, it is giving you p for primary, e for extended. By default it has selected what? Can you see that? P means it is primary, remember that. Okay, how many free partitions we have? 4. Okay, and the partition number is 1 default. Then the first sector, it has taken, you should always go with the default, go with the first sector. Then it is giving ending as a last sector. Don't go with the last sector. If you go with the last sector, it will allocate entire 20 GB to one single partition. No, you need to give a size in this order. Plus followed by the size, followed by KB, or K followed by GB, like this you need to go. So plus 2 GB, I'm just giving that. Can you see that? Press and enter. Then the partition got created. Can you see that? Now you put P for print. You will see that there is a partition with the name called SDA. One is configure. The size of the partition is 2 GB. The size of the partition is 2 GB, right? And ID is 83. ID is what? 83. Can you see this? It is 83. Okay. So what we will do is very simple. As the ID is 83 here. Now what I'll do is very simple. I'll just try to create one more partition. I'll just try to say N to create another partition, P for print. You see the number got reduced here. One primary is configured. The number has been reduced. Then P for primary, again, just understand second one is also primary, second partition. And see, for the first partition, this is a ending sector. Immediately the next free sector is been taken to the second partition. Can you see that? Press and enter. Then put plus 2 GB. Press and enter. P for print. Can you see the second partition is configured? Then again, I'll go with the third partition, just say N to create another partition, then P for primary, then see the third partition is selected. Then automatically this is the ending sector for this, and this is exactly new sector. Then press and enter plus 2G, right? Then the third partition also configured. Now you need to understand all the three partitions are primary only, remember. Then I'll just try to say N here to create a fourth partition. Automatically it takes E. E is nothing but extended. Can you see this? Okay. So, but what we will do is we will override this. We will say that I want to create fourth also primary. We will see this. Okay, I'm creating fourth also primary. I'm going to give the size as 2 GB here, P for print. So we have configured totally 4 primary partitions. Then I will try to create a fifth partition here. Just observe what it is saying. Try to read this message. To create more partition, first replace a primary with an extended partition. First replace a primary with an extended partition. That means until unless you will not replace a primary with extended, it doesn't allow you to create a fifth partition. Can you see that? This is what exactly happens. So what I'll do, I'll just try to delete a partition, D to delete a partition. Which partition you want to delete? That fourth one I want to delete. It got deleted. Can you observe that? Okay, it is got deleted here. Then I'll just again say N. After creating a 3 partition, whatever the disk space is left, we have to convert that entire disk space into extended, entire disk space into extended. So after creating 3 primary, 14 GB disk space has been converted into what? Extended partition. Extended partition. This is how exactly it's going. This is how exactly it's going to work. Is this clear or any doubts?
Clear, sir.
Right.
Yeah.
So after creating an extended, now let's create a logicals. Just say N to create a partition. See, it's clearly saying adding what partition? Logical partition. Then automatically it takes the starting sector and just give the ending sectors. I mean, you need to give the size. Whatever the size you want, you can give it. It's up to you. So there is, you know, above the extended is primary, below the extended is logicals. Is this clear? Right? So this is what exactly N, right? So plus 2 GB N. Okay, it's up to you how much disk space you want to allocate. You can allocate. I'm just creating it as 2 GB. Okay, so I'll just try to put plus 4 GB. Then P for print. I think still some disk space is left. 2 GB is left. Again, say N. Convert. Total disk space has been allocated. You will ask me, how do we know that all the disk space has been calculated? I mean, it's been allocated. Count this 2226 GB, then calculate this. Okay, don't count this. It will go beyond the 20 GB, right? Don't calculate this. You need to just go with this, and you need just go with this. This is a 14 GB. This is a 6 GB. Totally 20 GB it is going to give you, right? Otherwise, you need to calculate the sectors. This many sectors you need to see. Sometimes sectors may not. Here it is matching. Can you see this? This is the ending sector. Getting it? So this is the way. So as we have configured the partition, remember whenever you create a partition, by default the partition ID will be 83. 83 represents Linux file system. So you'll ask me, what is Linux file system? Linux file system, in a sense, what are Linux file systems? XFS, ext3, ext4, vfat, or btrfs. Okay, btrfs. This is all something called Linux file systems. Or we have a gfs version 2. This is also comes under Linux file system. Getting it? So this file systems only supported on this 83. Getting it, my point? That's very important. In some scenarios, you need to change this ID also. So you'll ask me when I'm going to change the ID. You need to press L to see all the IDs. This is all the IDs it is going to support. Take an example. You want to use this partition for LVM. What should be the ID? The partition ID should be 8E. If it is not 8E, it doesn't support for LVM. Remember. Okay, if it is not 882, it doesn't support for Linux swap. You're getting my point. Okay, if it is not EE, it doesn't support for GPT. Okay, if it is not FB, it doesn't support for VMware file system. You're getting it? These are some important things that we need to know, right? You will ask me, will the Windows file systems are supported here? Yes, 100% it is supported, right? If you want the NTFS file system need to be supported inside the Linux, then the ID of the file system, I mean, partition should be 86 or 87. Can you see this? This is what, but we never use Windows file system in it. It is long back we used to use it. Okay, now you will ask me, how do I change 83 to 80? You need to just press T and the ninth partition 80E. You need to just press P for print. Can you see this? It is 80. Yeah, this change. But remember, you need to change the ID of the partition when it is new. Now take an example. You have already created a partition. It has been created. A file system is created. It is mounted, and people are using it for storing data. Then later you will come and say that I want to change the ID. That's it. You will lose all your data, because this ID is nothing but the structure of your file partition. ID represents your structure of your file system. It is like a basement. If you destroy the basement, what happened? The entire building will collapse. Here, same thing happens. If you just try to change the structure, the entire file system and data will go down. Is this clear? Getting it? So this is what exactly it is going to happen. This is what exactly is going to happen. Any doubts? Yes. This is how exactly it's going to be. Done?
Yes, sir.
Yes, sir.
Right? So this is all about how do we create a partitions. Now you will ask me, how do I save it? You put W to save this. If you don't put W, all the partitions will get removed. It will just remove all the things and disk will become empty again. Right? And after saving, you want to verify whether the partitions are really created or not. Try to put fdisk-L followed by the disk name. Then it says that yes, the partitions are there. Is this clear?
Yes.
This is the way how do we configure partitions. This is all about. Then the disk naming conventions, we already discussed the disk naming conventions yesterday, right? SDA, SDB, SDEC. So whatever the disk that comes under SATA or SCSI or SSD, that all comes under, SDA, SDB only. Getting it. But nowadays, new disks are coming on on the hardware. New disks we are getting, that is called NV memory disk we call. So when you're using NV memory disk, then the naming conventions will change. And when you go with the SCSI, there are SCSI are of two types. One is narrow SCSI, another one is wide SCSI. Narrow SCSI will support 0 to 7 devices for one bus, one cable. Bus is nothing but cable. And wide SCSI is going to support 0 to 14 devices. Right now we are using VMware, right? It is going to support wide SCSI only. That means it will support 0 to 14 devices. After 14 devices, it will create a new controller. Remember, it creates a new controller. And remember the new disk that is called NV memory disk, that is called non-volatile memory express disk, it is called. This is a disk name and this is a partition names. Getting it? So you might see this kind of naming conventions also. And when you go with KVM, KVM stands for kernel virtual machine. Like right now we are using VMware, right? In the same way, if you are using KVM, inside the KVM, if you are creating a machine and you're trying to install OS in it, the disk naming convention will be like VDA, VDB, VDC, like this it is going to be, right? And as you know that /dev is a directory where you have all the devices names. So I'm not going much into it because we discussed detailedly yesterday, right? Is this clear? Okay. So this is all about how do we configure a partition. I hope up to here it's clear to you.
Yes.
Yes,
So
sir.
there is some
Yes.
more
Yes,
concept. There is some more concept regarding the partition. What is that concept? Is someone called you and said that, boss, you do one thing. I am giving you a 4 TB LUN or a 4 TB disk. Can I get a 4 TB disk? Physical disk 4 TB? Yes, you can. Okay, so you can get a 4 TB disk. I have a 4 TB disk and my client called me and said, I'm giving you 4 TB disk. You do one thing. I'll create 100 partitions here. Can I create? He's giving me 4 TB disk and he's asking me to create 100 partitions, or he's asking me to create 40 partitions. Can I create? Hmm? Can I create? You know, up to your knowledge, because we have discussed some concept here, right?
yes,
Can I create 40 partitions? Yes, really.
yes,
But just now we discussed that we can create only 15 partitions. We have discussed that we can create 15 partitions only, right? Then why my client is asking me to create 40 partitions or 100 partitions? Or suddenly my client called me and said that you do one thing, convert entire 4 TB, convert entire 4 TB into single partition. 4 TB into single partition. Can I create a single disk into a single partition, total 4 TB into single partition? Or sometimes client has gave me 10 TB disk, 10 TB disk into single partition. Can I create a single partition with 10 TB?
No.
No, really? Why not?
Like you said, if he's like when we create 10, then if we get any kind of virus, if it deletes,
No,
then
no.
you lose everything.
That is only on Windows, right?
Ah, okay.
No, I'm not talking about OS. I'm not talking
Okay.
about operating system. I have
Yeah.
gave you an example about operating system.
Mhm.
Because in your laptop, you're using laptop or desktop. I can't have a multiple disk there, right? We can have only one disk,
Yeah.
right? But when you go for servers, right? You know,
Mhm.
one single machine will support minimum 2 disk and maximum 12 to 18 disk also it will support. You know that?
Sure.
Okay. Or else, if not, take an example. I am having a one server which is having minimum 2 disk only. Okay. If the 2 disk is not sufficient, then what I'll do? I'll try to buy the storage, or I will try to take the storage lease.
Mhm.
Okay, from where I will take, like an example, you will take the storage from Amazon. Can I take the storage from Amazon? Rental. Can I buy a storage from Google? Can I buy a storage from the Google? You're using Google Drive. What is Google Drive? It's a storage only, right?
Okay.
Yes, so you could purchase.
Yeah, Google Drive. If your 15 GB is over, every month you need to pay $100 to opt 50 GB. You're getting my
Right.
point. It is rental purpose, right? Like this only, you can buy the storage from Amazon also. You can buy these storage from Microsoft also, because they are providing cloud services, cloud storages, same like Google Drive. Yes. Yes or no? Yes, we can buy. Or else, if you don't want to buy from third-party vendors, you can only buy a storage and put it into your data center, right? right? Storage like SAN, we have a storages like SAN. We have a storage called IBM-AIX. We have a storage called NAS. Yes, we can buy this, right? NAS is a file level storage. Okay, IBM-AIX and SAN is a block level storage. You'll come to know what is file level and block level later. Okay, example of file level is your Google Drive. Example is Google Drive. You're getting my point. Yes, we can. Okay, so when you're getting a storage from SAN, it might be 10 TB also. A single LUN, single storage, single disk can be 10 TB. This is my 10 TB disk. This is my 10 TB disk. 10 TB disk or whatever the disk that we are getting from SAN or IBM-AIX, it is not called disk, it is called LUN. LUN stands for logical unit number. LUN stands for logical unit number, remember. Is this clear? LUN stands for logical unit number because it is coming from SAN. That's a reason, right? So this is what. So my client called me and said that he need 100 partitions here. Can I create? No, I can't create because as you know that we can create only 15 partitions in one disk, right? So tomorrow we will discuss, can we create 100 partitions or not? Not now. Today, actually, I'm having another meeting in another 10 minutes. So what I'll do, I'll stop here for today. And tomorrow we have a session, ma'am. And same time we are going to meet and we will try to complete file system tomorrow.
I
Right.
think tomorrow is Saturday.
Yeah, tomorrow is Saturday, but
You're taking a class.
Yeah.
So is it okay if I go for the recording?
Yeah, no problem. You can go for recording. But I don't know whether, I mean, it will be easy for you to understand. But if you are still having any doubts, maybe on Monday, somewhere before the class or after the class, I'll just try to clear your doubts if you have anything.
Oh, okay, it's the same timing tomorrow?
Same time.
Yeah, I'll try to. If not, I'll go for the recording.
Sure.
Yeah.
Right. Okay, then. Thank you.
Thank you.
Right.